rulers coming along? Everybody have one yet? Okay, gloves.
Take a bunch of rulers and test
Oh, okay. Okay, I'll check it out. So you left me the number?
No,
Oh. Yeah, do you want those?
Let's play with the dice for roller. She fell on my hand.
Okay, have you guys all got a ruler right now? Everybody have a ruler? Okay, guys, today, like I said, probably one of the most important things that we're going to be talking about here the whole time. One question I'm going to ask you guys, have you talked about any initial value problems in science? When you look at me and I say initial value problems, and I say initial value problems, that, and you look at me, how many of you are looking at me like, I don't even know what you're talking about? Okay. Initial value means something like this. It's kind of like, well, okay, might be like a guy for starting a new job. They might say, you know what, you're going to start with a $10,000 signing bonus. So no matter what, as soon as I start working, I already have how much money? $10,000. And then they might say, you're going to have like a monthly salary of maybe $4,000 per month. Okay? So as soon as I walk in the door, I know I've got how much money? 10,000. And then each month, how much am I going to add to that?
4,000.
So 10,000 would turn into 14,000. Then the next one, 14 would turn into, and then 18 would turn into 22. And then basically we started at 10,000, and then over time, what happens to my value? It's going to get bigger and bigger and bigger. So that initial value is like right at the very second I start. So it's like when I have a stopwatch here, and I start, I'm going to hit the stopwatch at 0 and start. At time 0, I have how much money? 10,000. Initial value simply means how much are you starting? Where are you starting? Okay. And then you're either adding or subtracting values over time with that. That's kind of what we're going to talk about today. All right. Now, some things that we need to do today in this section to be successful is understand some things that we've talked about before, a little bit of slope and what a Y-intercept is, and that's exactly what Section 8.1 is about. Initial value problems that we've discussed here, and I'll give you a real life example here in a second. Initial value problems are going to be something like this. They're going to be what we call slope-intercept form. And this might be, again, like I said, probably the most important thing we cover all year in this whole chapter. Okay? You've got to be successful in this chapter this year if you're going to move into Integrated 2 next year, because there's a lot of this stuff, and they do a lot more with it. All right? So we're going to kind of get the nuts and bolts pieces of it here in this chapter, and we should be good. Goal-wise, we're looking at how to recognize the rate and initial value. Okay, there's that phrase again, initial value. You might want to make a note. Initial value is basically what you start with. Okay, I also have a word in here, rate. You're going to hear me refer to rate as a slope sometimes, so you might want to jot that in there. Whoops, that didn't go very well. Rewrite that. You might want to write this down as a slope. So a rate might be like a slope. When I talk about rate, when I came to work, I did the law-abiding citizen speed of 55 miles per what? I'm comparing how many units here when I'm comparing miles an hour? Two different units, okay? Or when I went and filled up with Governor Braindead's gasoline today, it was $2.54 per gallon. Dollars per what? Gallon. Yeah, thank you, Mr. Governor. Okay, I'm not bitter. I'm not bitter. Just a little upset. Okay. So if you ever hear me say the word slope or rate, they're used interchangeably. So if I say in a problem right here, somebody's going 60 miles per hour, isn't 60 miles per hour a rate? So 60 miles per hour would also be the, what's the word? Slope. Okay, so remember that. We're going to talk about how rates and initial values in real-life situations appear in an equation, and we're going to start looking at what the graphs are that represent those situations. Okay. First of all, we need to understand a slope in our vocab. Okay, what's the definition right here, kiddos? Rise over run. Okay. I'm going to make a sketch of a graph here. You'll want to do the same thing. So over in this box that you have right here, let's do this. Let's make a small XY coordinate like this. Okay. And I'm going to put a line in here like this. I'll say here's a line that goes from here to here. Like so. You guys see my line? It's a nice line. Ooh, fancy. Oh, I thought it was going to be fancy. But it's not. Oh, I like. You can put arrows on there. Okay? Cupid, you got yourself some competition, buddy boy. I got arrows too. Alright, I guess that wasn't very funny. Slope. Let's pretend there's 2 points that make this line up. Do you guys agree that that line that I've got there in the charcoal gray passes through those 2 points?
Yeah.
You can sketch those points anywhere. Okay? This line right here has got a slope between point to point. Let's just pretend here, like if I was counting, you know how on the dilations we said start at center and count up, count left, count right, count down, remember all that stuff?
Yeah.
Same thing here. Same exact thing here. Okay? The first thing I'm going to tell you though, by definition of slope, you should always count your what first though? Rise. So you're going to move up and or down first, right? You guys agree with that? Count up or down first. You okay with that? If I count up, what kind of a value is that? Positive or negative? And counting down would be a, and if I count right, count left. Okay. Check this out, kiddos. The first thing you always want to do is count up or down, then count left or right. So if I told you to go from this point to this point right here, let me do this quickly. Let's go yellow. Yellow. Going up and over to this point like so. Can you guys see that okay? Let me make that a little bit more gnarly for you. I don't want blue. There you go. Is that better? Let's just pretend between 2 points in the red that my rise here was, say, maybe, I don't know, 3. And maybe my run was 5. Rise is 3 and my run is 5. Okay? If I ask you what's the slope of that line right there from point to point, how far up or down do you count? Count up 3. So is that 3 positive or negative? And then, I always work from left to right. So one thing I would tell you, work from left to right. Okay? How far to the right or left do I go? 5 right. Okay. So my slope right here would be a slope of 3 over 5. Some of you might choose to divide that out. Some of you might choose to divide that out. And if that happens, if I go 3 divided by 5, what do I get as a decimal? 0.6. Okay, what that means is this. It means for every 3 units I move up, how many units to the right do I move? 5. So what if I moved up 6 units? How far right would I move? If I doubled the height up, how far right would you move? 10. Oh my gosh. That's kind of like that similarity thing again, isn't it? I double this, then I double that. If I went up 9 units, how many times of 3 have I gone up if I went up 9?
18.
So what would you have to do with the 5 here? Wouldn't you triple that? If I went up 9, isn't that like going up 3 different times? So if I go up 3 different times, I should go right 5 3 different times, shouldn't I? Make sense? Okay? So right 15. I'm going to write down this is the same as 0.6. However, I think for our purposes today, I would tell you to probably leave your slope as a fraction. Okay? Are both of these correct up here?
Yeah.
Okay, but which one's going to be your best? Which one's going to be your best advocate today? 3 over 5. Okay. Slope. A what over a what? Rise over run. Let me pull up a graph here. You don't need to write this down. Let's just practice this quickly. All right, here we go. Ooh, come on, come on, come on, come on. There we go. Let me put some lines up here, okay? Let me put some lines up here. We'll do it like this. Let's go from, say, maybe here to here. I'll get you a better color so that shows up. There, can you guys see that okay? Are you guys okay with that line? You know what, let me clean this up quickly. There we go. I'd like to know the slope of that line right there, all right? I'd like to know the slope of that line. Now, guys, I didn't give you any points, but is it possible that you could come into this graph and say, well, just looking at this line, it looks like I hit a corner right here, don't I? Don't I maybe hit a corner of a box right there as well? So sometimes you're going to have to go through and find the points that determine the line, right? Figure out what corners of the boxes does that line hit. Okay, so the first thing we said in determining slope, or rise over run, count your up or what?
Down.
Down. Start with the left point, count up or down. Okay? Am I moving up or down from this point?
Down.
How many units? So what kind of a value am I going to attach to that movement right there? Negative, negative 1. Good. How about the run distance?
2.
Positive 2. So how about the slope of this?
Negative 1
Negative 1
over 2.
over 2. Negative 1/2. What if I would have done this? What if I would have said, you know what, I don't want that point. I want this point and this point right here. What if I would have done that? How far down would I move? Negative 2 and then right how much? 4. Negative 2 over 4, right? But how does that relate to negative 1/2? It's still the same thing. If you simplified this, negative 2 over 4 would reduce to what? Won't 2 go into both of these numbers? How many times 2 into negative 2? How many times 2 into 4? 2. So when you get a slope, sometimes you might have to take that slope and do what with your fraction? When you get a slope, you might have to do what? Reducing. Now, reducing does not mean this. Reducing does not mean this. There, I reduced it.
No.
From house.
Right?
Right.
No. You get what I'm talking about, right?
Yes.
I'm picking up your point.
I like that. It's pretty funny. Okay, I saw that once. I thought it was pretty funny. Had to share. Okay, so let's go back to our, we know how to find slopes, right? Are we okay on finding slope?
Yeah.
Okay, one thing I want to point out is this. Go back to your front page of your notes. I guess you're already there. Okay. I'm going to kind of jump over the next two, and I'm going to talk about linear growth or linear decay. Linear growth says it's a line that increases from left to right. So if I start on the left and move right, it's going to go up or down? Uphill. It's like an uphill graph. Okay. Linear growth is going to be any line that has a positive, what's the word I'm going to attach to it? Well, positive slope. Okay, so if you ever hear me talk about linear growth or linear decay, linear growth is something that's moving from left to right. It's moving uphill. I want you to always think left to right in this chapter. Left to right. If I move from left to right, uphill means what?
Positive.
Positive slope. It's like the example I gave initial value. I started with $10,000. Each month I add $4,000. Is that growth or decay in the amount of money I have over time? It's growth. Okay. Linear decay. Seems like our temperatures lately, right? From what we're used to where they are now, what are the temperatures done this winter?
Decay.
They've decayed over time, okay? So if linear decay is what we're talking about, backing up here, linear growth was positive slope. What do you expect about linear decay? Negative slope. Yep. Means that if you move from left to right, the line will what?
Go down.
So negative slope. So the line's going to move down. All right? Line's going to move down. So if I go back to the examples I had that we were practicing right here, looking at our slopes, talk to me about that line, linear growth or linear decay.
Linear decay.
Two reasons why that's linear decay. What's one of them?
There's negative.
Slope is what value here? Negative. Slope's negative. Or I could say as I move from left to Right, is the line increasing or decreasing?
Decreasing.
Downhill, right? Okay, so you can either talk about it verbally or you can say, hey, attach a slope to it. It's either positive or negative. Okay, very good. Any questions so far?
No.
Any questions so far? All right, well, I think the next thing that I want to discuss then, what's the second term there? Does it say Y-intercept?
Yeah.
All right, Y-intercept. You guys see this term initial value right up here in our goal? See this term initial value right up here in our goal?
Yeah.
All right. We said that that's the point that you do what? Start with. I'm also going to tell you as well that the initial value for some of these problems that we deal with is also going to be the, what we call the Y-intercept. Your book is going to refer to it as vertical intercept. I always call it the Y-intercept. So if you see vertical intercept, just think what? Y-intercept. Okay, can we handle that? All right. Y-intercept says it's the point where what? Line crosses the y-axis. So I'm going to zoom up on this a little bit so I can squeeze this in here. I'm in that box over here on the right for this. Squeeze this in here quickly. Here comes your x and y axis right here. Okay? And then if this was your line passing through this right here, if this was your line passing through this right here, first of all, for that line right there, positive or negative slope?
Negative.
Negative. Linear decay or linear growth? Linear decay, right? That's pretty easy, isn't it? Okay, Y-intercept. What is the Y-intercept? The Y-intercept's like the initial value. What I will tell you is this. Do you guys agree that the vertical axis, or the axis that goes up and down, listen to what I say, the vertical axis is also my y-axis, isn't it? It's also the y-axis. So the point that we're talking about is the point where this line crosses which axis? See the point I'm pointing at? That point is going to be right there. This point is my y-intercept. Okay? That point's going to be your y-intercept. This is my initial value. In other words, that's where we will start stuff today. Initial value, where are you starting? What's the y-intercept? Okay, so if you hear me say vertical intercept, initial value, y-intercept, or where do you start? 4 terms I just said there. Start, initial value, vertical intercept, y-intercept. They all mean what? The same thing. Okay? They mean the same thing. If a y-intercept is positive, will you start above or below the origin?
Above.
If a y-intercept is negative, will you start above or below the origin?
Below.
Okay. So have you got that down? This point right here is my y-intercept. This point right here is your y-intercept. Okay? Squeezed in there. Can you guys figure that out? Can you guys figure that out? Okay. Now the most important part of the notes vocab-wise is right here in the middle. We're going to take everything we've talked about right here and we're going to put it all together. We're going to put it all together to what we call in this section slope-intercept form. Okay? We know what slope is, we know what the intercept is, right? Okay? What does it say slope-intercept form is here, guys? Y equals mx plus b. So what I'm going to tell you is this. M and b are going to be numbers. M is going to be the number that represents a slope. In other words, your rise over run. And b is going to be a value. Well, if m is the slope, what do you think b represents? We're talking about slope-intercept form. If m is the slope, what do you think b is? Slope-intercept form. Slope-intercept form. If m is the slope, what do you think b is? The intercept. Furthermore, which intercept?
A Y.
The y-intercept. B is going to represent your y-intercept value. So as an example here, kiddos, let's say I've got an equation here. Y equals 6x minus 2. Okay? Y equals 6x minus 2 as my example. Basically, I've plugged a number in for m and b, right? The y and the x are still there. What number represents m in that problem? 6. So my slope would be what? Slope would be 6. Now keep in mind, we said it would be really good if slopes were written in what kind of form? Decimal or fraction form? So when you have this slope of 6, you might want to think, okay, slope, rise over run, fraction. How would you write 6 as a fraction? 6 over 1. So what this means is this. It means you would rise up positive 6 units from one point and then run to the right 1 unit. A rise of 6 and a run of how much here? 1. Okay. What is the y-intercept in this? Be very careful on your y-intercept, please. Basically, the y-intercept is where do you start? -2. This sign that's in front, way important. Okay, this says don't start at +2. This one says start at -2. Okay. So we would start above or below the origin. 2 units below the origin. Okay. All right, vocab-wise, talked about a lot of stuff. I'd like to put it together here real quickly, but are you okay when I talk about the terms over here? Everybody okay on the terms here? All right. Let's jump ahead then. Let's jump ahead to the next page, and we'll start graphing some. Oh, no. Gosh darn it. Okay, so my graphs obviously don't look as pretty as yours. So we're going to improvise today, okay? I'm going to pull up a new sheet. Let me see if I can pull up a graph. I'll tell you which example we're on. So if I say we're on example 1, I'll have my graph up here. Is that fair for everybody?
Yeah.
Gosh darn it. Miller, do you have any Ford stickers I can slap on this thing?
No, sorry.
Brett, be nice. Remember, I still have an assignment to give out. Could make it really, really big. You don't want that, do you?
It's a gamble.
Hey, it worked. That Chevy idea and it took right off. Hey, we're on example 1, okay, guys? What does it say in example 1? What are we trying to find?
Find the slope.
Find the slope. I'm going to plot some points. Now, how far to the left and right and up and down does your scale go on your paper? What's the highest values? 9. Okay, so I'll stay in this window here. I'm going to pick 2 points to plot. I want you to plot the same points. I'm going to plot 0, 1 right up here. And I'm going to plot right 3 and up 7. And then I'm going to draw a line. So you do the same thing with your note paper. Plot those 2 points. And then what I want you guys to do is draw a line through those points that would extend all the way across your graph like I'm going to put up here. Oh, lordy, lordy, lordy. Okay, somewhat like that. Do you guys like what I have up there? Can you understand what I have up there? Okay, so I gave you those 2 points. Guys, let's just talk about some of the characteristics of that line. It's in slope-intercept form. It has a slope, a rise over a run, and it has a y-intercept, which we'll talk about here in a second. But guys, just looking at this right here, the 2 points that I gave right there, could you find a slope?
Yes.
Okay. What's your definition of slope again?
Rise over.
Rise over, run. So we're going to start, let's see, I said work from where to where?
Left
to right.
Left to right. So do I want to start at the point below or the point above?
Below.
This is the furthest left point right here, right? So what I would like to do is find a slope. So I like to draw the lines on a graph. This is what I like to do. Okay, I'm not saying you have to do this, but this is what I like to do. I like to draw from here up and then over and then count it. Okay? Draw up and then draw over and then count it. Come on, work. Work. Yes. What's your rise, kiddos? Rise is 6. What's your run?
3.
So the slope will be what over what?
Half. No.
Rise over what? Run.
6/3.
So in example 1, maybe off to the side of the graph or on the graph, I don't care where you write it, the slope is going to equal
6/3.
6 over 3. Now guys, we talked about this idea. We know how to reduce fractions, not the way I showed you. 6 over 3. 6 over 3 is pretty nice because 6 over 3 can just be divided out, can't it?
Yeah.
What's 6 divided by 3? 2, or 2 over 1. So I could simply say the slope in this is 2. What that means is for every 2 units I rise up, we go to the right, how many? 1. For every 2 units of vertical change, there's 1 unit of horizontal change. By the way, does it make sense that this would be positive?
Yeah.
Why?
Because it's not going down.
As I move left to right, it's moving
Up.
up. Or this would be an example of linear, what's the word? Linear growth. Okay? How are we feeling about this? Wonderful. Okay? All right, so I believe example 1, are we okay on example 1? And example 2 says, hey, let's find the what? Y-intercept. So do this for me real quickly. I'm going to start a new graph here, so give me a second. So we're on example 2 now, right? In your notes? So anybody watching at home, make sure you understand where I'm at. Example 2. Finding y-intercept, right? Plot these points for me. Plot, let's go left 5 and down. Let's go left 5 and down 3. That's 1 point. And my other point I'm going to have you plot is going to be right 3 and up 5, I believe, is what I want. Yep. So those are the 2 points I want. First one, left 5, down 3. The other one, right 3 and up 5. And I would ask you guys to draw a line through that. Okay, make it as accurate or as definite or as perfect as you can. Ah, shoot. Okay. Let's chat. What am I asked to find here? Y-intercept. Describe me what point I'm looking for or what.
On the vertical line.
So you're saying the y-axis, get on the y-axis and figure out where the blue line crosses what?
0. Median. Middle.
Crosses the y-axis, the vertical line. Where does the vertical line cross the blue line? Is that what you're saying?
2.
Okay, so right here, are you saying we cross right here?
C.
Okay, so what value is that?
2.
2. So the y-intercept is 2.
2.
Let me ask you some other questions. If the y-intercept's 2, what's the vertical intercept?
2.
Positive 2, right? Y-intercept, vertical intercept, same exact thing. Oh, by the way, what's the initial value in this problem? 2. Initial value is the y-intercept, right? Oh, where do you start this line at? All those things mean exactly the same thing. If I say start, initial value, vertical intercept, y-intercept, understand they all mean the same exact thing. All right? Questions about finding slope? Questions about finding a y-intercept? Okay, so let's jump ahead to example 3. 10:15 today. Everything's 15 this morning. So example 3 says find the y-intercept of the graph below and also find the slope, and then you're going to write an equation for this one. We're finding a slope, we're finding an intercept. And we're going to write an equation in slope-intercept form. You know what? I want to keep this same exact line for example 3. So I'm going to erase everything here. We're going to keep the same line. So I'm going to have you draw the same exact line for example 3. So let's do this. The points that I chose, I think I said left 5 and down 3, didn't I, kiddos? Pick that point. Pick left 3 and up 5. Plot that point. With your straight edge, go ahead and draw your line. That's pretty good. All right, I've got that same exact line right here, right? For example 3. Everybody agree? All right. In example 3, kiddos, our job is the following. It says, hey, we want you to find the slope, and we want you to find the y-intercept. Okay? And then they're going to say, write an equation for this line in slope-intercept form. So over here at the left, I'm going to jot some stuff down. Let's find the slope. Let's find the y-intercept. And then on the graph, I'll write down what we're asked to accomplish here. Okay? All right. First of all, is this going to be a positive slope or negative slope? Positive, as it's linear growth, right? So let's check it out. Let's check this out. I want to go from here to here. You guys see the 2 points we're highlighting? So I'm going to go up or down first, or left or right first? Up, and then over. Okay. So you guys do this for me first. How far up do we count from point to point? 8. 8, right? How far to the right do you count? 8. So talk to me about my slope, my rise over my run. What over what?
8 over 8.
8 over 8. Or 8 divided by 8 would be what value?
1.
Okay. So are we good on the slope being 1?
Yeah.
What about the y-intercept? Where's it cross the y-axis?
2.
Crosses right here at
2.
2. All right. Now the y-intercept is 2. Everybody okay with that? So here's what's most important for us today. We have to write an equation in slope-intercept form. Now keep in mind, guys, slope-intercept form is the form y equals mx plus what? What is going on? Y equals mx plus b. What did m represent again? What did b represent? So what would take the place of m? What value is going to take the place of m? Slope value, right? So my equation for this line is going to be y equals 1x plus, what's the b value? 2, right? This is the y-intercept. It's a positive 2, so write plus 2. If it was negative 2, instead of plus 2, you'd put minus 2. So the equation for this line, y equals 1x plus 2. Now I want to show you something here quickly. What does this mean? What's this all about? Put some points up here with a marker. Oh, what the heck. Guys, I'm going to put some points right up here. This point that I had right up here, this point was 3, 5, wasn't it? Is 3 an x value or a y value when I move right first? X, 5 is a what? Check it out. Guys, take that point right there. What's the y value when you plug this in down here? 5. Does 5, the y value, equal 1 times, what's the x value?
3.
What's 1 times 3 plus 2 more?
5.
Does that input, does that point right here fit into this equation or make it true? It does, doesn't it? Let's pick this point right here. Maybe this point, say, this point's 1, 3, isn't it? Guys, what would you plug in for the y value here at this point? Does 3 equal 1 times 1 plus 2 more? Yeah. Isn't this telling you what points to plot? If you have an x value to put in, it'll tell you what the y value is, then, won't it? How about this point right here? This point was negative 5, left 5, down 3, right? Well, help me out. Guys, what's the y value here? Does negative 3 right here for the y equal 1 times the negative 5? What's negative 5 plus 2 more? When I put these points in for x, doesn't this x determine what the y value is based on that equation you write in slope-intercept form? Got a question here. What if I threw 7 in for x? What would the y value be? What if I threw 7 in here? What's 1 times 7? 7 plus 2 more. So when I input 7 for x, my y output better be what? Which means 7 comma 9 better be on the line. Check it out. If I go right 7 and up 9, oh my gosh, is it there? It is, isn't it? Okay. Does it make sense? Okay. If I say, hey, here's a line. Can you find me, first of all, the slope? Can you find the y-intercept? Can you take those two values then and put it into an equation in slope-intercept form? Can you then use that equation right here to say, okay, if my x value is a certain value, to find a y value on this line? That's what's going on here. A lot of stuff, isn't there? Seems all pretty easy when we break it down, but when we start bringing it all together, it can get kind of lengthy, right? Right? Questions so far? Mrs. Miller, something to add at all that I've missed? Alrighty, well let's check this out. Where are we at? Example, does it say rules to graphic now? What if I switch the roles on you and say, you know what, instead of saying, hey, here's a line, figure it out. What if I say, here's the equation, I want the line now. Okay, so you have the rules to your notes, which are, I believe we're right about here, aren't we? We are right about here on your notes. Okay, and again, I'm not using my graph because, well, my graph's a lot prettier than yours, but, okay. I'll go back to the other stuff, but what are we trying to graph right here, gang? There's some rules up here. These rules, honestly, are pretty darn important. Right up here. Boom, 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 boom. I bet you'd like to see those rules, though, wouldn't you? Hang on a second. Is that more gooder? Is that more better? Oh my gosh, I can see. I'm cured, Mariah. Bring it. Oh my gosh. See their nose, their teeth. Shadows on it. All right, let's roll. What are we trying to graph here, kiddos? What are we trying to graph? Okay, let me clean this up. Okay, what was the equation again?
Y equals 1/2 x plus 2.
Oh, this is not working very well today, is it? Well, I'll keep digging now. Okay, I got some questions on some right there. I have some questions. The rules that you're looking at on that section right there, what's the first rule say to do, guys? Or what do they say when graphing this stuff right here? What's your first rule? We got to start somewhere, right? We have to start with an initial value. Initial value means where are you starting? See, initial value or start. That's really which point again it says in Rule 1? The y-intercept. Plot the y-intercept. Well, take a look at my equation up here. If this is y equals mx plus b form right here, what is the y-intercept, kiddos? What value? Isn't my b value this value out here at 2? Slope's always going to be right next to which variable? X. So the other value is your y-intercept. Okay? Y-intercept's a positive 2. So if a y-intercept is positive 2, does that indicate I'm starting above the origin or below the origin? How many units above? 2. Okay, so go up here, plot your point at 2. There it is. There it is. That's where we're starting. That's your initial value. That's your start. That's the vertical intercept. That's the y-intercept. Ooh, that's a lot of words. Okay. What's Rule 2 say to do then? says from the what?
Y-intercept.
From the Y-intercept, do your.
Rise over.
Well, what the heck is my rise over run or definition? That defines the slope, doesn't it? It says to rise up 1 and run how much? Let's see. A rise of positive 1. What's that mean?
You go up.
Up 1 over 2. Like that? So from not the origin, but from which point? From the Y-intercept. Rise 1, run 2. And now you've got this other point. And lo and behold, guys, once you've got those 2 points, what are you going to do with your straight edge? You're going to draw your line. Okay? Or if you're like me and you want to get really good at this, if I go up 1 and over 2, I might continue to do this over and over again to get a really accurate line. Up 1 over 2, up 1 over 2, up 1 over 2. Okay? See all those points right there? If you want a more accurate line, choose to do that. Okay? So here we go. Here comes our line. I tell you what, I love black and lime green together. Let's see it on time.
Oh, boom. Wow, nice. Look like our football socks.
Did you like that? Did you catch that?
I did. Alright,
I'm ready to go.
like a secret.
Start with which point first? Always start with so you're starting above or below the origin, and then from that point, always do your what? Slope. Now, I think that's the end of the notes, isn't it? Okay. I want to talk about one more example. Just please, please, please don't get caught on this, all right? Do not get caught on this. You're going to run into situations like this, and I should, before I erase this, I should slow down. Guys, what kind of a slope did I have here? A positive 1/2 or a negative 1/2? So does it stand to reason that this should be linear growth? I want you to think that way. Say, okay, my slope's positive, so it should be linear growth in the end. And we've got that there, right? Right? Okay? So, what would happen if I had something like this? Y equals negative 3 over 4x. Whoops. I want to write it like they do in the book so you understand what I'm doing. What if they start with something like that? So here's your equation in slope-intercept form. I want you to graph this for me. First of all, what's the y-intercept? So where am I starting, kiddos? So I'll be starting right here. That's a no-brainer. That's a pretty easy part. Now the thing that gets confusing is this. Some kids will say, okay, I have to go down 3 and left 4, because what kind of sign is out here? A negative. That is not true. Because if I go down 3 and left 4, what kind of a line would you have? It'd be linear growth, wouldn't it, though? Do I want linear growth? I want linear decay. So what I'm telling you is this. If you ever have a negative attached, to a slope out here in fraction form, always, always, always take that negative and put it with the top number, which means the top is really negative, but the bottom is a. So talk to me about my directions of movement from my initial value. You're going to move down 3. So there's 1, 2, 3, and then how far right?
4.
Okay, and my point would land right here, wouldn't it? So before I even draw that line, you might want to say, hey, do the 2 points that I, was it 5? Wow, learn to count, math teacher. Jeez. Was that really 5?
Yeah.
You're messing, right? You're for cereal? You're for cereal? That's what?
That's
Now you got me wondering. Is that more gooder?
yeah.
Okay. If you're happy and you know it, clap your hand. One person's happy. What in the world's going on here?
Fry talk.
Hey, before I even draw that line, check it out. Linear growth or linear decay? Okay, is that going to match what we had up here in this slope here? Okay. What questions have you guys got? All right.
Is there
I tell you what,
No worksheet.
I will make you a deal. Since I don't have your test graded, I'm not going to give you an assignment over the weekend.
Good.
We'll hit this probably Monday, right?
You have reality sheet.
Can we go to advisory next?
No, third hour then advisory, isn't it?
Yeah.
After third hour, isn't it?